Now we are going to see how a galvanometer can be converted into a ammeter. So electrically, we can model galvanometer. Yes, I'll show it on the screen. You can model it like this. So this is the galvanometer, and we can consider its resistance in series with it, and that is Rg. So this is galvanometer. When I connect a small resistance, very small resistance known as shunt resistance in parallel with the galvanometer resistance, this assembly becomes an ammeter. So this assembly inside the red box is an ammeter. Okay. Now, when an ammeter is connected in series with a resistance to measure current through that resistor. So if I want to measure resistance of, if I want to measure current through this resistance R, I will connect the ammeter assembly in series with this R. Now the battery voltage is V. Without ammeter, the current through R is V by R. And after connecting the ammeter, the current through R should not change. It should still remain V by R. Now let us see how is this possible. Now, if we try to find the effective resistance of ammeter, it will become Rg times RSH, because Rg and RSH are in parallel, divided by Rg plus RSH. Now the shunt resistance that we have chosen is very, very small compared to the galvanometer resistance. So Rg plus RSH is approximated to Rg only. RSH is very, very small. So we can ignore RSH in the denominator. So this becomes Rg, RSH divided by Rg only. And in numerator, there is an Rg. In denominator, there is an Rg. We can cancel it out. And the effective resistance of the ammeter becomes the shunt resistance, that is RSH. And RSH is very, very small. Because the R is in series with RSH, R plus RSH will again be R, and the current through this resistance will still remain V by R, because the total resistance now becomes R plus RSH, and the current is basically V by R plus RSH. Okay, and R plus RSH is R, and this is equal to V by R.